And start that recording now. And in terms of the source material, the student usually brings the material just because I really don't know what you're doing in class. So it makes much more sense for you to bring the problems to the table. Those can be verbalized. A typical precalculus question can probably be verbalized. If it's unique in that it's asking you to interpret a graph or something, well, then you'd probably need to take a picture of that and send it to my email, and then I can bring that up on the screen, and we could look at it. But for tonight, if you have some problems that you can verbalize that we could talk about.
Let me take a look.
Okay. What kind of stuff are you covering in pre-calc right now? Are you on Trig or are you on pre-calc?
We're doing Trig right now.
Okay. Have you just started Trig this semester?
Yeah, we were doing mostly like algebra review last semester, and we started doing right triangle Trig
Okay.
this semester. So.
Okay. How you doing in your pre-calc class right now? What kind of grade are you? What'd you get for the first semester?
First semester I got a D.
Okay. So Trig kind of starts with this.
Yeah, we've been doing that quite a bit.
So if I ask you to tell me what the sine of theta is,
that would be 3 over 5.
Okay, and the tangent of theta?
3 over 4.
Okay, good. That's a good start, knowing those trig functions. What's the reciprocal of sine? Do you remember?
Would that be cosecant?
Yeah, it's 1 over cosecant. This is 1 over secant, and this is 1 over cotangent. And one way, and these are very important here. You want to definitely memorize these 6 reciprocal functions. And notice that each one has a co in the pair. There's the co with the cotangent, there's the co in that pair, and there's the co in that pair. So if you ever are wondering whether cosecant goes with cosine or sine, you'll always be able to know for sure that it goes with sine.
All right.
So what would the cosecant of theta be in this problem, this triangle that I've drawn?
Cosecant would be 5 over 3.
Yeah. In other words, these reciprocal relationships work both ways. Cosecant is also equal to 1 over sine. Okay, well, it sounds like you got the basic stuff down pretty good. What kind of stuff are you working on right now? Or what kind of stuff are you having difficulties?
So right now I have in front of me, let me just kind of read the directions to you, and I'll give you an idea.
Okay.
So evaluate without using a calculator by using ratios in a reference triangle.
Okay.
And then it just says tangent 300 degrees.
Okay. Unit circle you've clearly had.
We went through it more thoroughly today.
You know, I think I can make this easier for you. Most of the schools in Colorado give you this giant unit circle. They divide it up into 16 parts, and they say memorize each of these points for all 6 trig functions. In other words, that represents a 30-degree angle. These are all multiples of 30, 45, or 60, or 90.
Yeah.
And that's the way they want you to do it. Well, I got a real problem with that. The human brain doesn't memorize 16 things very well. If I gave you a 16-digit number to memorize, you wouldn't memorize it as a 16-digit number. The best way to memorize it would be to maybe break it up into 4 groups of 4 numbers each and memorize it that way. Same thing with trig. If you can memorize the first quadrant angles, the common ones, 30, 45, and 60, then you can relate every other angle that's up to 360 to one of these. And that's the easiest way to learn trig. Now, let me draw the special right triangles that you've been learning about for 3 years in algebra and geometry. And that's the 30-60, 90, and the 45-45, 90. If you can remember these 2 pictures right here, then you can get any of the trig functions for your 30, 45, or 60-degree angle. For example, what's the tangent of 30 degrees?
That'd just be, would that be 1 over root 3?
Yeah, for starters, that would need to be rationalized, but yes,
right.
That's correct. In other words, it would be 1 over root 3. You wouldn't want to give that as an answer. You'd rationalize it into root 3 over 3. But in terms of trig, trig's about ratios of triangles. So 1 over root 3 is fine, as long as you know how to get that. What is the sine of 45 degrees?
Would that be root 2 over 2?
Yes. Now, they may teach this to you and give you one that looks like root 2, 2. And that's fine. Some school systems do that. Doesn't matter. I like to think of these as my unit triangles, meaning the side opposite the smallest angle is always 1, and go from there. But you should be able to see that these 2 triangles will allow you to answer any of these 3 angles right here. Okay?
Right.
Now, when they talk about a reference angle, let's say we had a 150-degree angle. Positive angles are always measured counterclockwise. The reference angle they're talking about is this angle that is made with the x-axis. In my picture there, what is theta?
That would be 30 degrees there?
Yeah, if we use this formula, theta minus, 180 minus theta, we get the equivalent first quadrant angle. In other words, if I said the sine of 30 degrees is 1/2, which it is, well, the sine of 150 degrees, the first thing I want to do is figure out what is that equivalent first quadrant angle, which is the same as this reference angle there. Well, it's 30 degrees. We can see that. and we can get it by subtracting the 150 from the 180. So you can always get the reference angle in the second quadrant by subtracting your angle from 180. Okay, you with me for starters?
Yeah.
If I go to the third quadrant, I can get the reference angle by subtracting theta minus 180. In other words, if I had a 210 degree angle, 210 minus 180 would be 30. So I'm looking at the equivalent trig function to a 30 degree angle, minus the sine. And finally, in the fourth quadrant, it's 360 minus theta. Okay? So your problem here, tangent of 300 degrees, which quadrant is that in?
That would be the fourth quadrant.
Okay, so what's its equivalent? I call it the equivalent first quadrant angle, but it's the same thing that they're calling the reference angle. So what would the reference angle be?
So I would do so it would just be 60 degrees.
Okay, now let's figure out what the tangent of 60 degrees is, based on my two triangles here.
That'd be root 3 over 1, that is root 3?
Yes. Okay, so we have our absolute value. We know that it's root 3. Now all we need is a plus or minus sign that matches. Well, there's 4 more letters here that are important. All students take calculus. Have you heard of that?
No.
What it means is that in the first quadrant, all 6 trig functions are positive. In the second quadrant, only the sine and its reciprocal, obviously, are positive. In the third quadrant, only the tangent, and in the fourth quadrant, only the cosine. So what is the plus or minus sign for tangent going to be in the fourth quadrant?
Minus.
That's exactly the best way to do these problems.
All right.
Okay, let's do another one. Hold it. Let me first of all erase most of my stuff here that I have. Whoops, I don't want to erase the S. If you want to memorize anything, this is what you want to memorize. Everything you're looking at right now. In fact, if you had a smartphone, take a picture of this page and commit it to memory. And now, let's do another problem. Let's do the sine of 225. So what's the first step?
Find which quadrant it's in. So
Okay.
That would be, we would do 225 minus 180.
Yep. So that's 45, right?
Yeah.
So that's the reference angle, 45. Now look at these two triangles and tell me what the sine of 45 is again?
Root 2.
It's, in our case here, it's 1 over root 2, which rationalizes to root 2 over 2.
Right.
Now all we need is the plus or minus sign.
That would be minus.
That's it. That's the way you can now do every single angle in the unit circle that is a multiple of 30, 45, or 60, which leaves your quadrangles. Your quadrangles are 90, 180, and 270. Okay? Have they given you a special way to learn those?
No, not really.
Well, let me there's a couple of other things you really need to memorize. The two most basic would be your graph of the sine function and your graph of the cosine function. Notice that each of these graphs breaks into 4 quarter points that represent your quadrangles, and they're also the 4 key points for that function. You know which function this is? The top left one?
Oh, you said that was for sine?
That is sine. And the bottom one is cosine. This is y equal cosine x. Notice that both of them bounce back and forth, and I'm only drawing one period here. You know that these go on forever in both directions, right?
Yeah.
Okay. So now if I said to you, what's the sine of 90 degrees? Look at the graph and tell me what it is.
That would be 1.
Correct. What's the cosine of 90 degrees?
0.
Uh-huh. Now, you can do every angle, as long as it's a multiple of 30, 45, 60, or 90. Even angles greater than 360. If I said, what is the sine of 390? What's the first thing you'd want to do?
Find the reference angle, which is 30 degrees.
Uh-huh. And then just read the 2 triangles, figure out. If you want to memorize any trig function, memorize that the sine of 30 is 1/2.
Okay.
Okay, that's worth memorizing. Also, the cosine of 60 is 1/2. Those two come up so often that rather than always having to have your memory refer back to these 2 triangles, it's better to just memorize some of those. In fact, memorizing all of the first quadrant, 30, 45, and 60 isn't a bad idea, because these reference angles that get created are basically the first quadrant angle, and we can figure out the ratio, the trig ratio, from those. Now, let's talk about negative angles for a moment. Have you dealt with negative angles yet?
Not really.
Okay, let's not deal with those yet then. I don't want to get ahead of where you're at in your class.
All right.
Although,
we've touched on them, but we haven't really gone into
the only difference, a positive angle starts from here and goes counterclockwise. A negative angle starts from here and goes clockwise. So if I wanted to draw a negative 45-degree angle, that's it right there. Same as a positive 315-degree angle. Okay? There are a couple of rules for negative angles that are worth knowing, but like I said, I'll wait and let your teacher talk about those when you get to them in class. But one thing I'm 100% sure of is that everything on this page you need to memorize. I tell that to every single trig student I have, and this is kind of my standard Trig 101 lecture, because all of this is important, along with the SOHCAHTOA. SOHCAHTOA. Okay? Now, have you dealt with radians?
Yes.
Okay. So you know the conversion factor between radians and degrees is either pi over 180 or 180 over pi, depending on which way you're going.
Yep.
The key is pi is equal to 180. So if I'm dealing in radians, I'm not going to be using 180 minus theta. I'm going to use pi minus theta. So let's put that in there and memorize it. And then instead of theta minus 180 in the third quadrant, it would be theta minus pi. And in the fourth quadrant, it would be 2 pi minus theta. In other words, if they said, what's the sine of 5 pi over 6? Well, you don't have to convert it to degrees and do all the work. You can work directly with this equation right there. If I said, what's the sine of 5 pi over 6, the first thing you'd do is pi minus 5 pi over 6 gives you pi over 6. So there's the reference angle. And pi over 6 is 30 degrees, so you can use this triangle and this angle. Okay? So now our picture is complete. If you memorize everything you see there, you will be able to answer any trig function without your calculator, as long as it's not an oddball trig function. In other words, as long as it's multiple of 30, 45, or 60, or 90. Okay. Let's see. We've only got a few minutes more here. What else should I address here? There are a few trig functions that, for example, the tangent of 0. There's one other graph that's not a bad idea to memorize, not as important as sine and cosine, but still relatively important. Tangent. And what I'm drawing here are vertical asymptotes. Tangent is always increasing and goes from negative infinity to positive infinity. So if I said, what is the tangent of 90 degrees? What's the answer?
So would 90 degrees be?
Pi over 2.
Okay.
So from reading this graph, that's infinity. Or they may prefer using this terminology, undefined.
Yeah, we don't really do that.
You don't use infinity, or you don't use undefined?
We normally use undefined. We don't do the infinity thing.
Okay. Notice why infinity is slightly better. Because what's the sign of minus pi over 2?
Negative infinity?
Yeah. And yet your teacher would say they're both undefined, but there clearly is a difference. One is going to positive infinity and the other is going to minus infinity. So at some point...
We
No, that's okay.
use undefined, like, because in the unit circle, like when you're dividing them to get the tangent, you end up having 0
as the denominator, exactly. Exactly. When you divide by 0, you get undefined. But when you talk trig and you talk the unit circle, there is positive infinity and negative infinity. And in fact, as you get, what year are you in, Daniel?
Yeah, senior.
You're a senior? Okay. As you get closer and closer to calculus, you will start using infinities because there is a difference between positive infinity and negative infinity. And if undefined is the only terminology you use, you can't really distinguish between them. But I understand why they do it. They pretty much use the word undefined up until calculus. Mainly, I think, because they don't want people to think infinity is a number. It isn't. It's a concept. Infinity merely means to grow without bound. But there's a difference between growing large without bound and growing negatively without bound. And so that's the advantage of using infinity. What's the tangent of 0?
Would that just be 0?
Uh-huh. And there's one more point on here that's worth knowing for the tangent curve, and that's the tangent of 45 degrees, and we know that that's 1 from our triangle here. For some reason, on most tangent curves, they don't label this point right here. even though I've always thought they should, as opposed to the sine and the cosine, notice that you can't have the sine of an angle be 1.5. No such beast. It's either, the only range for this function is -1 to 1 for sine and cosine. Whereas notice the range on the tangent is -infinity to +infinity. And that's the other advantage about using infinity, is you can put it in interval notation. If your teacher said, what's the range on the tangent function, undefined isn't going to work. You're going to have to say -infinity to +infinity, or all real numbers. Whereas the domain is not all real numbers on the tangent function. You can't have pi/2 or -pi/2. You can't take the tangent of those numbers. And the same thing with your secant and cosecant. Obviously, if the cosecant is the inverse of the sine, well, whenever sine is 0, you got problems with the cosecant, right?
Yeah.
Well, the cosecant curve looks like this, and it also has vertical asymptotes wherever sine is 0. So your cosecant curve, your secant curve, your tangent curve, and your cotangent curve all have vertical asymptotes periodically, whereas your sine and your cosine don't. All right, that's probably a good place to stop. That gives you a real solid Trig 101 foundation. Do you have any questions or anything about what we covered today?
No, that makes more sense now.
Yeah, this method they have of giving you this giant unit circle and saying memorizing it, that's for the birds. Notice that the way we did it, we only had to memorize at most 3 things at a time.
Yeah.
The 3 dimensions of that triangle, the 3 dimensions of that triangle, the 180 minus theta, theta minus 180, and 360 minus theta, that's 3 things. All students take calculus, that's 4 things. So by memorizing a group of 3 or 4 things, it allows you to answer this question that they ask, which is, give me the trig function of all 16 slices of this circle. And there's 6 trig functions at each slice. So they're really asking you to memorize 96 things. Well, you can answer every one of those 96 things now if you've got this page memorized right here. Okay?
All right.
Daniel, I'm going to let you go. This initial session is only a 30-minute session.
Okay.
And let's see, how did you make, first of all, how did you hear about me? Was it from your...
I asked my counselor for a list of tutors.
Okay. And then, so you probably went to my website, Algebra to Calculus Tutor, and made the appointment on that.
Here, let me see where I am.
I actually have 2 websites. One is Algebra to Calculus, which looks like this. And that allows you to schedule sessions online. But I have another one that's actually a little smoother and a little easier, that probably, if you're going to do everything online, probably use Digital Math Tutor. Same thing, it's me, it's only my website, both of them. This one also allows you to schedule. This one makes it a little easier to pay using PayPal. There's no charge for this first session, it's free, but future sessions I do need paid either, not necessarily in advance, but before the next session.
Okay.
Okay? So if you want to memorize one or take one down or save it in your favorites, why don't you save Digital Math Tutor? and use that
yeah,
one.
I just wrote that down.
Okay,
So.
and it's got my same phone number on it. To schedule a session, just click there, click on the book now, same exact way you did it before. This one, like I said, makes it a little easier to pay, a little smoother. Well, Daniel, I hope I've been helpful, and I hope to work with you more.
Okay.
And I'll let you just go ahead and schedule online. That'll show you my complete availability, and it's probably the easiest way to go. If you ever discover that you like a certain time of day, say maybe this 4:30 on Friday works perfect for you and you want to lock it up, just let me know, and I have the ability to do that on my end. The scheduler doesn't give you the ability to do that. You can schedule out a couple of weeks in advance only, but I could lock it up for the whole semester if you wanted it locked up.
All right.
Okay? I will let you go, and you have a good weekend.
You too.
To close out a Gotomeeting, you just need to close on that X in the upper right of that gray panel. I will talk.
What did you say?
You can close out the Gotomeeting by
Yeah.
clicking on the X of that panel in the upper right.
All right, there we go.
Okay. I will talk to you next time, Daniel.
All right.
Bye-bye.
Thanks.
Bye-bye.